Good afternoon, everyone. I want to thank everyone for joining us today on this webinar, and we'll begin here in just a few minutes. Good afternoon, everyone. I'm Ryan Siegel. I'm joined by my colleague Sean Maurer here for today's webinar. Today's session will be approximately 1 hour, and certificates will be sent out for all participants. For those of you who may have questions during the presentation, please feel free to go ahead and use the question and answer function that should be found towards the bottom of your screen. So go ahead and click the Q&A, and that should open a pane that you can ask your questions in. If you do ask your questions in the chat feature, we may or may not see those. But go ahead and feel free to go ahead and put in your questions in the Q&A pane, and we will try to answer those either as a course of the presentation or towards the end of the presentation. So today's webinar is being recorded, and that recording, along with the PDF of the slides for today's presentation, will be posted to our website at SEDAC.org. So as far as a few learning objectives, obviously today being plan review and site inspection for commercial lighting. So looking to understand plan review requirements and site inspection requirements, along with some of the documentation practices and best practices to show energy code compliance and hopefully minimize any callbacks or re-inspections that may be required. So trying to help expedite those processes for design teams and code officials and the like. So a little bit about who we are. We are SEDAC as part of the University of Illinois. We're housed at the U of I at Urbana-Champaign, and our primary mission is to reduce the energy footprint of the state of Illinois and also beyond. So this energy code training is one way that we do that. As far as being the energy code training provider for the state of Illinois, today's program is sponsored in part by the Illinois State Energy Office housed at the Illinois Environmental Protection Agency. So we do want to thank them for their sponsorship of today's program. Also noted that we will be providing certificates for today's participants. Also in that email, if you are an AIA or ICC member and need those credits, there will be a link in that email for you to use to provide us your member name, member numbers, and emails for submission of those credits for you. So. We do have, as part of our energy code training program, a technical support helpline. So if you or project team do have questions regarding the Illinois Energy Code, could even include code officials or building occupants and owners, feel free to reach out to us at energycode@illinois.edu. We do have an 800 number, but we do prefer the use of that email, so that way that allows us adequate review time, and we actually have discussions in the office to make sure that we get you a good, complete answer for your questions. We also have several online resources at our website, and some of these include archives of our past workshops and webinars. We do also have several online on-demand training courses, so those can be completed at your leisure. And each of those takes approximately an hour and a half to complete. That also provides links back to our technical support helpline. So if you forget or misplace the information, you can reach us smartenergy.illinois.edu/energy-code. We also provide many links to various resources, including the Illinois Energy Conservation Code, several frequently asked questions, particularly about have several roofing questions and other envelope related questions, and many other useful websites. Some of those websites include links back to the International Code Council's website for the 2018 International Energy Conservation Code, which is the basis of the Illinois Energy Conservation Code. We also have links to that Illinois Energy Conservation Code amendments, as well as the City of Chicago Energy Conservation Code. So rather than trying to remember a big long string of characters, again, you can come over to our website, and under helpful links, we can link you back to there. One question that I would anticipate we will get at some point today is regarding the 2021 International Energy Conservation Code and when that will be adopted for use in the state of Illinois. We're anticipating that the adoption of the 2021 International Energy Conservation Code will occur sometime in the summer of 2022 for the state of Illinois, probably somewhere around July of 2022 is when the 2021 International Energy Conservation Code will become the basis of the Illinois Energy Conservation Code. So we do have several upcoming workshops and webinars. We are coming towards the end of our season for this year, for this program year, ending at the end of June. And we are planning our next year's, our 2022 workshop season. So if there are particular topics that you would like to see covered as part of our workshops and webinars series, again, go ahead and feel free to reach out to us and email us those ideas that you would like to see as part of next year's series in energycode@illinois.edu. So if you would like to register for any of these upcoming webinars or workshops, Again, feel free to see our webpage, smartenergy.illinois.edu/events. So before we get too far into the various code, first wanting to detail when does the Illinois Energy Conservation Code apply? And for most projects, it is the requirement to apply for a building permit that triggers the requirement to comply with the Illinois Energy Conservation Code. The International Building Code does list out several different items that are normally exempt from permits, including electrical repairs and maintenance, portable gas equipment, such as portable barbecues or outdoor heaters, and things of that nature. And while these are listed in the International Building Code, since we are talking about commercial buildings, do check with your local jurisdiction, because they may have other things that are either exempt from the permit or items that may be on the International Building Code list that that your local jurisdiction may still require a building permit for. So do check with that. As far as identifying, the code is broken into commercial buildings and residential buildings. And so for the International Energy Conservation Code, any buildings that are not defined as residential buildings are therefore commercial. So that includes commercial, industrial, institutional, most government facilities, and the like. So Illinois does have a specific amendment to define a residential building, so we do like to call that out, that there is an Illinois state amendment to this. They specify that a residential building is any detached one or two family dwelling, or multiple single family dwellings and multiple dwelling units in buildings that are 3 stories or less in height above the grade plane. If you are in the city of Chicago limits, then that increases to 4 stories in height or less, in which occupants reside on a primarily permanent basis. Those are residential buildings, and then commercial is everything else. So here you can see several examples of commercial buildings, including the nice city of Chicago skyline. On the upper right-hand corner, we have a multiple occupancy building that is greater than 3 stories, or even in the city of Chicago, greater than 4 stories in height. So that would also be considered a commercial building, and also the public library would also be a commercial building. So I want you to be aware of that. So with that, I'm going to turn it over to my colleague Sean Maurer, talk about some of the plan review and documentation items.
Okay, well, thank you very much, Ryan. So to get into what is required by the Energy Code to be documented as far as your lighting and electrical systems. So if you look at section C103.2, there it documents that the lighting fixture schedule should be included with wattage and a control narrative for applicable lighting systems. Usually that fixture schedule is in a plan drawing by itself. And that satisfies that first part of that documentation as far as having that fixture schedule. We're starting to see more and more those fixture schedules have a summary for the lighting wattage that applies to each of the fixtures in that schedule. And so that complies with those 2 components of that requirement. But the control narrative is kind of variable in where it's placed. We've seen it located in the specification documents as a write-up in paragraph form. We've seen it in a specific lighting control drawing set that has the control narrative or some kind of schematic breakdown of the control system. And we've also seen sometimes where it's included in that fixture schedule as an intent for control for the different lighting types. So there's multiple different ways that can be noted. One thing we would suggest is in documenting that location and stuff is that you refer to that control narrative with your lighting plan drawing so that it's easier to locate for the code official. Either putting it on a summary page for code compliance or in a code compliance section to your specification manual, just noting where that location is so it's easier to find. The construction documents requirements also list that a plan drawing should be provided that labels the daylight zones in a building. It's a sheet that can have either shaded areas or hatch marked out areas. It just denotes for side lit areas and skylit areas what area of that floor is going to be part of that daylit zone and therefore needs to have daylight controls for lighting contained in that area. And just an example of what that might look like that we have seen, this is just displaying that daylight zone for a side lit area tilted in onto the floor plan around the glazing on the wall. And it just indicates that the lights in those areas need to be controlled by daylight control systems unless they meet the minimum requirements for reduced energy consumption that would exempt daylighting controls. So let's get into a little bit of the plan review and just some examples of what this might look like. It's very common for lighting fixture schedules to have fixture wattages included with them for the different lighting types. As we know, figuring out the wattage for a fixture has to include the lamp wattage, the impact of ballast factors on that total wattage consumption. And so documenting that in a single location makes it easier for plan reviewers to go through and note as they can then go back through the drawings, count up fixtures, and figure out lighting power densities. And this just helps with the plan review process and speeding that up. One thing we don't see as often is an actual calculation of the wattage per square foot calculation. Sometimes this is included on a code compliant sheet as a summary at the start of the lighting documentation and plan drawings. But it's somewhat hit or miss. But for code officials, this does help speed up that review process. That helps them to be able to spot check compliance for the drawings more quickly. So we do like to note that if you can and haven't yet started this process, go ahead and start calculating your wattage per square foot, either through the building area method or the space by space method, and document that in a table. And we actually have an example tables that ASHRAE provides, and these can be copied over and expanded for your project into a plan drawing. That is just helpful for documenting that watt per square foot calculation. And so these tables, again, they're available on the ASHRAE website as a resource for code compliance documentation with the 90.1 ASHRAE codes. But these can also be used for documenting compliance with the 2018 IECC if that is your chosen path. The one thing I will note is if you're opting to use the space by space documentation method, it does give you a little more flexibility as you can trade off lighting power allowances between different spaces. What you're going to want to do is total up the total space area for the different space types on this table. And that way it's easier to document your total lighting power allowance for each space type. And as you get in your plan drawings, you may want to add on the floor plan where you've got room labels, a label underneath that that denotes what type of space that is that ties back to this summary table. I have not seen, we just had a question come in, does the IECC have similar forms to ASHRAE like this? I haven't seen forms like this. We can dig around a bit, and if they are available, we will post them in our resources page. But I have not seen an IECC resource like this. If you're documenting lighting power density in ComCheck, it does all those calculations for you, and so that reporting and verification for code officials is significantly easier. You can see circled at the top of the image here the allowed wattage and the proposed wattage for the lighting system. And ComCheck does all those calculations for you. Again, if you're doing a space by calculation method to give you a little more flexibility and allow for trade-offs. ComCheck does help track what spaces are allowed to have trade-offs versus what spaces are not, and that your total wattage allowance does align with what is calculated by ComCheck. So it's a little bit easier using a software program. The grand majority of compliance projects do use a ComCheck process. But it's good to know that here we're showing a building area method calculation. If you do use a space by space method, it does break those out into individual space related total summaries. What about track lighting and low voltage lighting? Documenting that wattage and compliance. On plan drawings, we have seen a count of fixtures as a kind of a summary add-on, a call out to track lighting or low voltage lighting that then calculates the affixed wattage to that track lighting system. The energy code does call out 8 watts per linear foot is the minimum. Another way is you could indicate the current limiting device in a circuit drawing summary page or control drawings page that has the maximum wattage allowable for that system. And for low voltage lighting, the transformers are called out in plan drawings. That transformer will indicate a maximum wattage. Those are all different ways to document the lighting power allowance for track lighting and low voltage lighting systems. So before we move into lighting controls, do have a poll question. We'll launch that question here just on which items need to be included on your construction documents. Fixture input wattage, lamp wattage, the quantity of lamps, the lighting control narrative, or the daylit zones. This is a multiple answer question, so pick all the ones that apply. Still got some answers trickling in. We'll give it a few more seconds here. Okay, so let's share those results. So not all of these are required, although it looks like everyone, we got a nice even spread here. It seems to indicate that people believe that. But per section C105, you just have to include the daylit zones, the fixture input wattage, and the lighting control narrative out of this list. The number and quantity of lamps isn't required for documentation in the energy code per the C105 and C103 documentation requirements. It's just the input wattage for each fixture type, the control narrative, and those daylit zones. I will pass it back over to Ryan. He'll start touching on documentation for lighting controls.
All right, lighting controls. This is one area where there's a fair number of different requirements and very detailed items as far as including the different control strategies. And so first starting in the warehouses, and the code calls out 3 different areas where they have control requirements for occupant sensing controls. First being warehouse storage areas, second being open plan offices, and third being anywhere else that has occupant sensing devices. So starting in the warehouses, requires that the lighting power has to be reduced by at least 50% when the aisleway or the open area is unoccupied, that the control zone is. Off is perfectly fine, but the important thing here is it has to go down by at least 50%. And understandably, we need to make sure that we're controlling aisleways separate from open areas, because if we have people here working in this aisle, we don't necessarily need to light the aisle that's beside them. Only the one that they are in needs to be at full brightness. So also making sure that we control the aisleways separate from the open areas. Again, open areas is kind of treated as a separate aisleway because you may have forklifts or people going between the different areas. So almost treated as a very large aisle. As far as our open plan offices, there's a few different requirements. First, this applies to open plan offices over 300 square feet, because if a open plan office area is under 300 square feet, then the lighting control requirements for all other areas would apply. So once you're over 300 square feet, then an individual control zones cannot be larger than 600 square feet. Understanding that an individual sensor may go a little bit over 600 square feet. It's not uncommon to see these cover 1,000 square feet or a 10 by 10 area, but understanding that each of the control areas needs to be no larger than 600 square feet. So if you have 1,000 square foot open plan office, even though the single sensor may cover the full 1,000 square feet, you would have to have at least 2 occupant sensing devices and 2 different control zones, one for each of the approximately 500 square feet area. So also calls out that once a zone is unoccupied, then within 20 minutes, the lighting has to be reduced by at least 80% in that zone. And then once all the zones in that open plan office area is determined to be unoccupied, then the remaining 20% also needs to go off. So that's something where you can either do this with multiple zone sensors that are linked together, or perhaps an easier way to do that is just use individual control zones, and instead of reducing it by 80%, they just go full off when that zone does not have any occupancy sensed. As far as our control sequence, understanding that the write-up needs to note as far as how that's going to work. So if you're going to reduce the lighting by 80% in a given zone and then intertie the sensors such that the goes to 100% off, once all zones are unoccupied, then that could be in the control narrative, or you can just say that the control that the zones will go to 100% off when occupancy is no longer within that zone. So, but making sure that you do write up what that sequence is, if you're doing this with linked zone sensors or just individual zone sensors. Also noting here that 20% or that 20 minutes of unoccupancy is the trigger point, or no greater than 20 minutes. Some spaces, particularly now with LED technology, because they don't mind switching nearly as much as the old fluorescents do. It's not uncommon where we see certain locations that may be less than 20 minutes, where you have a 10-minute or even just a 5-minute delay. So also understanding that daylit or daylighting controls should only turn on if there's occupancy sensed in that zone. So we don't want it where at the end of the night or at the end of the day, the sun goes down and all the lights in the daylit zones come on because there's no longer adequate daylit or daylighting, even if there's no occupants in that area. So the occupant sensor should be the command control function for turning lights on. and then only if a zone is on would the daylit sensor modulate that lighting back down. So, in several places where throughout the code, lighting for safety and security is allowed to be excluded from various controls and various calculations. And so here we're noting a few of those different things, some of those being safe passage lighting, stairwells and security checkpoints, and also egress lighting that is normally off. So these would commonly be your bug eyes on the walls or other battery backup lighting that's normally off and only comes on in the event of a loss of utility power. So that's fine to be excluded. If you are going to exclude some of these items, you do have to have these approved for exclusion by your local code official for excluding them from the calculations. Normally we see people go ahead and just include everything as far as our wattage allowance. You just go ahead and include everything except for perhaps our egress lighting that's normally off. That would normally be excluded. But for safety and security, for the power calculation, typically that's just easier to include. With the wattage allowances now, many of these are in the 0.6, 0.7, 0.8 watts per square foot. We are now seeing designs easily in the 0.5 or lower, some even as low as 0.3 watts per square foot. So even including the couple of night lights or safe passage lights generally does not cause much in the way of consternation. So one way to do this is to make sure that you have a tabular summary of your control strategies. And here is calling out some of the different occupant sensing controls as far as different areas. Here indicating many of these areas have to be auto shut off within 20 minutes. Some of these, like warehouse areas, have to be reduced by at least 50%. And so on and so forth. A couple of these, there's a couple of options here where the occupant sensing devices can either be a manual on, typically called a vacancy sensor in the industry, or they can be auto on, but only to 50% lighting output. So a manual on is normally called a vacancy sensor, where an auto on is typically called an occupancy sensor. So just being aware, some of these there's an option as far as which way you go, but the important thing is to actually document what is it going to be for you. So here, this is one example of it, where here we're dictating as far as in a break room, we're going to use a vacancy sensor. So this is going to be a manual on push sensor. In exterior parking lot lighting here, we're actually using an occupant sensor rather than a time clock. So when you get into exterior lighting, you do have a couple of different options there as well. So again, the important thing here is documenting what are the different controls. We'll also touch on this a little bit later as far as commissioning, because time clocks, occupancy sensors, vacancy sensors, and daylight harvesting sensors all would have different requirements as far as what are you going through and checking. So your sensitivity, your is it getting false triggers from HVAC equipment? Is it not shielded properly such that someone walking down the hall just turns on every light, every office light as they walk through, even though they're just walking through the hallway, and the like. So having this breakdown as a tabular summary can be very useful when it comes to developing some of the documentation for commissioning. Commissioning of lighting controls has become much more substantial. So as And also as part of this, Sean mentioned earlier, as far as there is a threshold for daylight harvesting controls, which if you are able to get below that threshold, commonly it's 0.6 watts per square foot or less, then you can eliminate the need to buy, purchase, install, commission, and maintain those daylight harvesting controls. So being able to drive your watts per square foot down and installing a more efficient lighting system can also help simplify some of the work for you. So beyond your general lighting, there is also separate requirements for application lighting. So things like store display cases, accent lighting, signage, and making sure that we have separate controls for specific applications as compared to our general lighting. So again, more controls means more commissioning. So trying to reduce the complexity of these controls to the best of your ability is likely to lead to the best long-term performance, because the more complexity there is, the more likely things will go awry into the future. So with that, I believe we have another poll here. So as far as our lighting controls, looking at it as far as where are they required? So this is just to choose one. Warehouse storage areas, open plan offices, almost all spaces now, restrooms, or private offices. Again, not sure if we do have any other questions coming in. So if you do have any questions, go ahead and feel free to use that question and answer function found towards the bottom of your screen.
Okay, looks like we have most of our answers in, so we'll go ahead and share those poll results.
All right. Looks like most everyone got it. Nearly every space now requires lighting controls, either via time clock or occupant sensing devices. So yes, all of these would be, they are required in warehouse storage areas, open plan offices, restrooms, and private offices. So with that there's a list of at least 11 different types of spaces for occupant sensing devices alone, plus you have your time switch. So lighting controls are required almost everywhere now.
Okay, now we'll move on to looking at, what should you expect for the lighting inspection as a code official comes out? What are they going to be looking for on site? First thing we're going to touch on is kind of the comparing the original plans to the actual as-built conditions in the building. So they're going to be comparing those floor plans, any updated as-built plans to make sure that the lighting wattage, the lighting types that have been specified in those drawings are what's actually installed in the building, because that does have an impact on the overall lighting power density. So they're going to want to be verifying that that is correct. They're also going to be matching up locations and just in general making sure what you've documented for compliance in your plan drawings, your as-built drawings, your specification manuals is what's been installed in the building. They're going to be checking to see if any new fixtures that have been updated in the plan, changed out, budgetary constraints, things may have changed the type of systems that's installed, making sure that those aren't using more energy than was originally intended, particularly if you're doing an energy budget model, as that can have an impact on whether that model complies or not now. They're also going to be checking on fixture performance as far as lighting output, lumens per watt, making sure that complies with requirements for the spaces. There's also now fixtures that have variable output and color temperature. As buildings that are advancing in technology, we're doing different scene modes for buildings for different applications in a space. A conference room may have bright white lighting for a general meeting and then have dimmer lower color temperature lighting for presentation modes to reduce glare on surfaces. Um, and so reviewers are going to be looking at what's that maximum output from those devices and making sure that that then complies with your watts per square foot lighting power allowance. The other thing you're going to be checking is that your lighting controls work as specified. Um, One thing you're going to want to be aware of is for occupancy sensors in private offices or smaller rooms, that you don't want those pointing into common areas, as that can create false triggers that turns that lighting on when no one's in the space. It's particularly common when you've got glass dividing walls between offices and private areas where you're trying to create that open feel to the interior of a building, allowing daylight to penetrate deeper into spaces. But if you have an occupancy sensor that's not properly located and can trip from someone walking past those windows, that greatly increases the lighting demand in that space. So they're going to be verifying that those sensors are properly located to avoid false triggers and things like that. They're also going to be checking the sensitivity setting on those sensors, so there's not false triggers just from the air handling system kicking on. I've seen ultrasonic sensors set too close to supply grills that then trip just from the vibration change in the airflow pattern. We also commonly have had that issue with passive infrared sensors, where in classrooms or other spaces that may have hanging decorations from the ceiling, that those airflow patterns can then create a false trigger on those systems and turn lighting on when no one's in the space. So being aware that sensitivity settings need to be properly set on those devices, that they're only going to trigger when there's somebody in that space using the area. Another thing that's going to be checked for your daylight harvesting, if you do have daylight controls in the building, making sure that those can actually see the daylight in the space. You can see here an example of one that's been hidden by the ductwork in the bottom right corner here. So it can't actually see the daylight coming into the space. It can't adjust the lighting relative to the foot candles in the space because it can't see it. So again, verifying proper location of those devices so they can actually see the space and control it, and proper sensitivity setting and proper control settings on those devices so that they only trigger as needed for daylight or occupancy sensors, um, and that they're not going to false trigger from environmental effects such as the HVAC system kicking on or other non-occupant related activities in the space. The lighting controls do need to also be specified appropriate to the application, and that's something else that'll be checked. You don't want a passive infrared sensor, a standalone sensor, in say like a multi-stall restroom application, as the lighting may turn off while someone's in that space. So you're going to be looking for either a dual technology or a ultrasonic sensor in that space that can pick up activity that's obscured by objects in the space. It's also pretty common for cubicle wall office spaces or spaces where activity level, you've got minor movements and things that may not be picked up by a passive infrared sensor. It's better picked up by an ultrasonic sensor or dual technology sensor. And so it's another thing that's going to be checked for during these commissioning processes, is that lighting's not going to turn off on occupants in the space because they're not the proper application for what's being for the space type. As we go through the different lighting device types, we get into time clocks. Those need to be inspected for proper scheduling of the initial settings. Make sure that complies with the original documentation for schedules for the building. They also need to verify that if there is a power failure, that those settings are backed up for a 10-hour period at a minimum, and that system can then recover and continue to run on its schedule once power is restored to the building. You're going to be spot checking controls, make sure they're connected to the proper bank of lights, that they've been properly wired up. I know I was commissioning a building as a retro commissioning agent, and they had the controls to the lighting switches wired up in reverse. So a lighting command from the BAS, the building automation system, to turn the lights on would actually turn them off. And that did create some confusion in the operation of the building and setting up schedules and things. And so it's just going through and verifying through a commissioning check that the things are properly set up, that they're going to work with the proper commands. If you've got a building automation system, or if they're wired up to an occupancy sensor, that the proper signals are having the proper impact on the lighting controls. For daylight sensing and outdoor controls that are hooked up to photocells, making sure that those photocells are properly located. They shouldn't be blocked from viewing ambient light. They shouldn't be in a highly shaded area, or they won't turn lighting off as daylight allows. And they should be pointed away from obstructions. I've seen a number of times with photocells pointed at the wall they're mounted on, and that can cause issues. Having the photocell in direct sunlight can also be an issue, as that can shorten the life of that photocell. So you do want to locate it somewhere where it's not exposed to direct sunlight, but still has the ability to view diffuse ambient light so that it can control daylight based on what's sensed for daylighting controls. For multi-tenant structures, where you've got permanent residences, or say you've got a shopping mall or some other type facility where you've got multiple tenants with occupancy in that building. For this particular measure, it's specifically dwelling units, apartments, townhomes. Those do need to be sub-metered in some way, and that sub-metering does need to be documented in the plan drawings and does need to be verified on site. The means of doing that sub-metering can vary, though. Most commonly, you tend to see that bank of utility meters on the wall for the utility company to easily come up and read for the different tenants so they can bill them separately. But we have also seen in buildings where that metering is done through a building automation system, and it's tracked as kilowatt hour consumption through the BAS system to different utility meters that are then, instead of having the separate bank of utility meters on a wall, it's all done through the building automation system. So you might have a single utility meter, and then the building owner or facility owner would then manage distribution of tracking individual tenant usage of energy consumption. So just being aware that there are different ways that this sub-metering can be done for dwelling units. Again, the most common is to have that bank of utility meters so the utility company can do all that sub-metering reading and billing to tenants directly. But we are seeing a little bit more often now where it's tied to a central BAS system and monitored that way. And as Ryan alluded to earlier, if you have proper documentation in your plan drawings of a control narrative in a tabular format, it's easy to take that format and expand it out into a commissioning checklist. So you can see here we've expanded out different office room numbers. The reason this is important, why you can't just use your original controls tabular check sheet, is because each space that has different geometry needs to be commissioned independently. So if you have a series of rooms, probably a good example is classrooms, where you've got one classroom that the next classroom over is just a mirror copy of that room. Because it's a mirror copy, you've changed the orientation of that space. Those two spaces need to be commissioned independently. If the classrooms have the same orientation and geometry, then you can do a sampling protocol and essentially just commission every few rooms that have the exact same geometric setup. And that includes orientation of the room, not just the shape of the room. And so that's why you can take that tabular format and expand it out to the different rooms with different geometry types and create a verification checklist. And this kind of helps speed up the generation of the documentation you need for that commissioning process. So we do have one last poll to launch here. We're going to go ahead and get that started. What are some key areas for inspection during that site inspection process and commissioning process? So time switch programming and backup supply, dwelling electrical metering, changes from approved drawings, occupant sensing controls, daylight harvesting, and completed commissioning of documents. And again, if you do have questions, please feel free to enter those into the Q&A window. We'll be glad to address those. Any specific questions on any particular requirements, we'll be happy to address those as well. Okay, looks like we've got most of our responses in. We're going to go ahead and share those poll results. So all of these are key areas to that site inspection, and we've got that broad range of answers. So it looks like most people picked up on that all of these things need to be checked and verified, and they are important in that site inspection process and in commissioning of the building. Well done to everyone.
As far as, I know Sean had really touched on this, as far as commissioning being a key item here, as far as who has to develop the commissioning documents, it is up to the registered design professional or the approved agency. So this could be either the architect or engineer of record for the project, or there are many third-party commissioning agencies out there. And so that may be something where reaching out to and involving the commissioning agent early could be very beneficial for projects to avoid any delays. That commissioning agent may also already have preloaded templates for some of this documentation, which then the project team could use as part of their project submittals for plan review, which again can be useful as far as trying not to reinvent the wheel, rather than the architect or engineer developing something that then the commissioning agent has to go back and either rework or is in a different format than they're used to. And as with these control verification worksheets, being able to extend that out as far as, if you have an occupant sensor going through and saying, do I have sensitivity right? Do I have daylight harvesting? Is there any false triggering? Is there, there could be, this could extend out a fair bit, and doing that for each or almost every room in a building can be fairly time consuming. So do have a question as far as can the registered design professional delegate this? Again, this goes back to or an approved agency. So if it's not going to be the design professional of record, and that is going to be delegated, that does have to be approved, which means acceptable to the code official. Frequently, we don't run into too many issues where code officials, if the design professional is farming it out to a commissioning agent to do that development, we don't normally see too many code officials pushing back and saying, no, it's not acceptable that the person who is going to do the commissioning develops the plan as far as how they're going to do it. But so that can be farmed out. But again, just check with your with your code official to say, hey, I'm looking to farm this out. Here's going to be the commissioning agent of record, because there are many firms out there that specialize in doing the building commissioning. That could even be HVAC commissioning, lighting commissioning, or something. Could be separate as well. So as far as another related question, as far as can the contractor be the commissioning agent? That is potential. Again, it goes back to whether the code official finds that acceptable. And so you may find that on smaller projects, code officials may say, yeah, that's fine if the installing contractor goes through and does the commissioning, because as part of the site visit verification and inspection, the code official would likely be looking to double check some of that work too. So for a smaller project, I'm even thinking a small retail establishment, convenience store type of thing. Uh, the controls are not going to be very complicated, and so just verifying, yeah, the controls are there, they are working, it may be fairly simple for them to commission. But on larger facilities, it wouldn't be uncommon for that to be farmed out.
If you have a clarifying question as well on, we had mentioned simplifying controls and reducing, if you reduce your space wattage, power density enough, then daylighting controls are not required to be installed. And so to touch on that requirement, if you can take your budgeted, your code maximum allowed lighting power density, and you can reduce that by a weighted average of the spaces that are being controlled for daylighting by, I believe it was 10%.
40%.
40%. Then you can omit the daylighting controls as a requirement. And so if daylighting makes up 10% of your floor area, then you only need to reduce your lighting power density by 4%. Beyond that, the lighting power density is listed in those code tables, and then you don't need to have those daylighting controls installed. Okay. I don't see any other questions coming in. We haven't seen any in the chat either. So if there are no further questions, we'd like to thank everyone for attending today. Hope you found the session informative, and we hope you can return for our remaining presentations in the rest of this program here.